This is my presentation. My presentation is bringing a Star Wars BD1 droid to life. The goal of this project was to move a bipedal robot across the ground. A little bit about me. I am a computer science undergraduate, and I also work as a software engineer at Lightning Kite. For this project, I am working on getting a bipedal robot to move across the ground. Not programming it directly, but using temporal difference learning so that it is able to gain feedback from the system and learn and adjust environment. I want to do this because I want to better understand how temporal difference learning works, especially in a actual application. It's also really cool to see robots move kind of like us. This is kind of a general view of the observation, state, action, space, and reward structure. It looks a little bit complicated, but it's pretty simple. We have the robot position in the environment. We have whether or not it falls. We have each of the joints have a position and velocity we can send to them. Well, for the action space, but each of the joints and the velocity have a position for where they're at in the X, Y, and Z. In the action space, we can send commands to each of the joints. So we can send a position, velocity for each of those joints that you see listed there. And then for the reward structure, each time it traveled on the X or Y axis in a positive direction, it would get a positive reward. If it didn't move, it would get 0. And if it fell over, then it would get a -1, or it would be over for the that simulation. So for the how of this project, I used the ROS gazebo environment. I started with the GitHub repository here as a starting point. I had the model and all the things that I needed. It used different algorithms to do similar thing to what I was working on. It used TensorFlow, but I'm not very familiar with it, so I decided to go with PyTorch. As well as I'm also implementing a totally different algorithm anyway. I was implementing temporal difference learning. Here we have a graph showing the cumulative reward for each training episode, but you can see that it did learn things that at times it would take actions that would get it all the way up to a reward of 6. Here we can see the reward received at each episode during inference. It did really good at the very beginning, and then it kind of flattened out in at the end, but then it figured things out at the end. Here you can see the cumulative reward during inference. Here you can see it shows a lot of the same thing the other graph did, but it's just a nice little step showing that it's going up. It does go down at the very end, but that's when it falls over and it can't get back up. So the end result was that it learned to move by using its head to pull itself forward. Not exactly the way I wanted it to, but I don't think it was possible with the way the motors are. So eventually I want to make it so there's some hip joints to allow better balancing and to allow it to balance its weight better, as well as add a gyroscope to the head and the body to help it balance so that maybe it can actually move its head. Right now I had to lock its head to get it to do this part, but it's kind of fun to watch it move. It moves in a weird way, but it figured out how to move, even if it's not the way we expected it to. So just kind of dragging itself forward.